We've already looked at the conversion of cyclopropane to propene and shown that it's a first-order reaction. And we also found the rate constant at 500 degrees Celsius in an earlier video. And so the rate constant is 6.7 times 10 to the negative 4, 1 over seconds. And so in part A, if the initial concentration of cyclopropane is 0.05 molar, what is the concentration of cyclopropane after 30 minutes? Well, to solve for this concentration, we can use the integrated rate law that we found in an earlier video. Since this is a first-order reaction, the integrated rate law, or one form of it, is the natural log of the concentration of A at any time t is equal to the negative kt, where k is the rate constant, plus the natural log of the initial concentration of A. And here cyclopropane, or C3H6, is A. So this is the natural log of the concentration of cyclopropane, C3H6, is equal to K is 6.7 times 10 to the negative 4. So this would be negative times 6.7 times 10 to the negative 4. And time, we need to find the time. And since we have K in seconds, right, we have 30 minutes here. We need to convert 30 minutes into seconds. So 30 minutes, right? There are 60 seconds in 1 minute, right? 60 seconds in 1 minute. So if we multiply those two, right, minutes cancels out. So 30 times 60 gives me 1800 seconds. So that's 1800 seconds, so I put that in here. So 1800 seconds plus the natural log of the initial concentration of cyclopropane, right? The initial concentration is 0.05, so this is the natural log of 0.05. So starting to run out of space there. All right, so let's think about what we would do to solve for the concentration of cyclopropane. All right, well, we have this natural log in here. All right, so we could exponentiate both sides to get rid of our natural log. So if we exponentiate both sides, that gets rid of our natural log here, and that would give us the concentration of cyclopropane after 1800 seconds. So let's do that math. Let's get out the calculator here. Let's do all that math on the right side. This was let's see here. We have negative 6.7 times 10 to the negative 4. We need to multiply that by 1800 seconds. And to that, we're going to add the natural log of 0.05. And then we need to take e to our answer, right? And e to our answer gives us 0.015 molar. And so that's our answer. Our concentration of cyclopropane is 0.015 molar. Now, you didn't have to use this form of the integrated rate law. You could have used a different form, the concentration as a function of time, right? So you could have written the concentration of cyclopropane, right, at a certain time is equal to the initial concentration of cyclopropane. Right, the initial concentration, e to the negative kt. So we saw this in the previous video, so the concentration as a function of time. So we can plug in our values here. We're solving for the concentration of cyclopropane. The initial concentration was 0.05, so we plug in here 0.05. E to the negative k was 6.7 times 10 to the negative 4, and our time was 1800 seconds. So we could do the problem this way. Obviously, we should get the same answer. Let's just go ahead and show that here. So we have negative 6.7 times 10 to the negative 4 times 1800, right? And then we would take e to our answer, and then we need to multiply by the initial concentration of 0.05. And so obviously we get 0.015 molar again. So it doesn't matter how you do the problem, right? It doesn't matter which equation you start with, you're going to get 0.015 molar for your concentration of cyclopropane. All right, let's look at part B of this question. How long does it take for the concentration of cyclopropane to reach 0.01 molar? All right, so to reach 0.01 molar, once again, it doesn't really matter which form you use, which equation you use. I'll just take the first equation that we discussed, right? The natural log of the concentration of A is equal to negative kT plus the natural log of the initial concentration of A. And let's plug in what we need here. So the concentration of cyclopropane to reach 0.01 molar. So that's our concentration here, right? That's our concentration at some time. So that would be the natural log of, this would be 0.01 molar is equal to negative kT. So this is negative 6.7 times 10 to the negative 4. The time is what we don't know, right? How long does it take? So we're trying to find the time. And we know the initial concentration of cyclopropane. Once again, that's 0.05 molar. So this is the natural log of 0.05 molar again. All right, so to solve for time, this would be the natural log of 0.01, right, minus the natural log of 0.05. And then you'd have to divide that by negative 6.7 times 10 to the negative 4. So just some algebra here gets you your time. So we can do that on our calculator. All right, we can take, let's make some room over, let's put it over here. All right, so this would be the natural log of 0.01. And then we're going to subtract the natural log of 0.05 and then divide that by negative 6.7 times 10 to the negative 4. And then we get as our time 2,402. Right, that's in seconds. Right, so 2,402 seconds. Time is equal to 2,402 seconds. And we could leave it in seconds, or we could put that into minutes. Right? So how many minutes is that? Well, 2,402 seconds. If we divide by a conversion factor, this would be 60 seconds in every minute. All right, so seconds would cancel out. We get 1 over minutes, and so that gives us minutes, of course. And so we could do that really quickly on the calculator, or you could do that in your head, right? I'll go ahead and do it on the calculator just to show you, right? Let's take that and let's divide it by 60. Obviously, we're going to get pretty close to 40, right? So once again, that's something you could do in your head, but 40 minutes. So approximately 40 minutes is how long it would take to reach a final concentration of 0.01 molar. All right, let's look at part C. All right, so in part C, they want us to find the half-life. Well, from the previous video, for a first order reaction, the half-life is equal to 0.693 divided by your rate constant K. And so the rate constant for this reaction was 6.7 times 10 to the negative 4. So the half-life is equal to 0.693 divided by 6.7 times 10 to the negative 4. And this was 1 over seconds. All right, so we can do that on our calculator to solve for the half-life. So we have 0.693. Right, divide that by 6.7 times 10 to the negative 4. And so we get 1,034. Right, so T1 half, which is the half-life, which is 1,034. And the units would be seconds. Right, this would be 1 over seconds or seconds. So 1,034 seconds. If you wanted to convert that into minutes, right, we could just divide that by 60 seconds, and that gives us 17, we'll just say approximately 17 minutes. Right, so we'll round that to approximately 17 minutes is the half-life. And remember from the previous video what the half-life refers to. So if we started with, remember we started with a concentration of 0.05 molar, right? That was our initial concentration. The half-life is how long it takes, right, for us to get half of our initial concentration. So how long does it take to go from 0.05 molar to half that, which is 0.0250 molar, right? That's the half-life. It takes 17 minutes. Right? It takes 17 minutes for our concentration of cyclopropane to go from 0.05 molar to 0.025 molar. And how long would it take for our concentration to reach 0.0125 molar? Right? So this concentration is half of this. So therefore, it would take another 17 minutes. So again, watch the previous video for more on half-life.